Hi, I'm Dr. Ron England, and this is Module 5, Lecture 2, our second lecture on data modeling with ERD, or Entity Relationship Models. First thing I'm going to do is look at just some of the notations of the relationships. These should be ones that you're familiar with. They should actually kind of make sense. A one, hey, it's a one, many, one and only one, zero, one or many, or zero or many. In fact, you may want to actually just write these down and throw them off to the side here until you kind of have those memorized. Because as we're working through these different examples, we're going to kind of go over these relatively fast. I'm not going to stop and dwell on every single one and say, hey, that's a one-to-one, a one and only one, because I'm just not going to do it. You should be able to look at that and make that determination. So let's look at some examples. In this case, we're going to take a pattern here. We've got some part information. And notice that you've got, with these parts, you've got the company, city, and price on a separate line, with the assumption that the part number and the name is common to each individual row. But what we're looking at is a company, a city, and a price that goes with those parts, which would basically be specific suppliers. And how would you model this type of information? You're looking at information or data or spreadsheets or forms or all sorts of stuff. When you're trying to model stuff, you're starting with usually something that you've already got, an existing system. And that system is probably not going to be a database system. They're going to say, hey, can you take this form where we capture 1,000 pieces of information and produce a database? And of course, you can always say, hey, well, let's just figure it out as a flat file. But reality is you're probably not going to do that. There's probably better ways to actually model the patterns. So looking at this other one, you can kind of see that quotation piece, those pieces of information which are repeated, have a many relationship back to the part. And if you could say, well, they also have a relationship back to the company. But does the company go with that part piece? So, but it is pretty obvious that you've got a quotation that is dependent upon at least both of those pieces. The quotation deals with the part, and the quotation comes from a company. So you have those relationships. So in this case, many or zero or many. You don't necessarily have to have a company to go with the quotation, even though it kind of makes sense to have that. But you've got the ability, you're basically getting the information from two pieces of information. It's a part, okay, and it comes from a specific company. So in this case, I think that you're really safe in saying for the quotation, you want to have both of those pieces of information, okay? And that actually kind of matches the data. So as you're working your way through these types of problems, you're going to look at this and say, where are my dependencies, and how can I actually take that? And what are my entities going to be? This looks like a fairly logical entity diagram to go with the information that you had in this previous piece of paper where it had parts quotations to it. And one of the ones that you can deal with on a fairly regular basis is the concept of the good old, like the phone number. You've got a pattern here where you've got multiple phone numbers that go with something. So let's say we got that company. Well, what are we going to do with, how are we going to manage the phone numbers? Numbers almost always being the case. So do you make that phone number an attribute? Or maybe it's specific phone numbers that are an attribute. But then again, how do you know, what if you make business phone and then an individual, some other phone numbers that go with it, maybe business, direct line, and a fax number, and then you find out that there's more that you need to actually keep track of. So you always got to make that decision. Do you break off phone number as its own piece of information? And in this case, I would say here's the company. Now I've made it its own entity, but I also may put in the what phone number is it? I mean, what is the description of the phone number? So you have phone number, company name, and a description piece. What should be the phone number description? Okay. You've also got the ability to have patterns like, in this case of the company, you've got the phone number. You've got contact information that goes with the company name. The company name is just a pointer back to the original entity. So there's a phone and a contact specifically for that. But now what do you do if you have a specific situation where you've actually got the contact? You want to keep track of the contact has a relationship to the phone. Yes, you have to consider these situations. But You can have multiple contacts for the company. You can have multiple phones for the company. The contacts can potentially have multiple phones also. So you may want a way to deal with that, but we're not going to talk about that one just now, because what now we're really looking at is this specific multi-valued pattern that you're going to be dealing with. But you can see how it's relatively easy to manage this pattern. It's essentially what you'd call a one-to-n relationship. There is. One of the patterns that you deal with all the time, the archetype instance pattern, it's very common. An abstract parent, but something that's logical. So in this case, let's say a painting and a print. Well, the painting would contain attributes, as an entity would contain attributes that are common to all instances of paintings, but print being a specific instance of that. Or in the case of a class and a section, well, we can definitely think of sections as instances of a class, but you can also look at that on like a per semester basis too. So the basic instance pattern here is pretty easy to spot. Those are, I like the class section one because it really is a good one that tells you, hey, you've got that one class which can have multiple sections that go with this, and it is ID dependent. The section does need to keep a pointer back to the class that it's a section of. So, when you put these things together, you can say, okay, well, what have we got here? We've got the class and with description that's going to be common to all the sections of the class. And then you got the section, which points back to the class, which was described by the class name, but it has its own descriptive ID, which is the section number, and then things would be specific to a section. Okay, and I'm not going to go over yacht design and house model. Those are just all different. They're different from class, but they all follow that same specific pattern. And you can kind of see a yacht itself, however, has that ability to be. It actually has the ability to be weak, and it has the ability to also be strong. And that is going. In this case, we're dealing with those as weak instances, but they're not ID dependent in this case. And this is specifically a decision point where you're going to make decisions about how you want to model that data. And a lot of the time it's going to depend upon how that data is going to be used. So again, I'm going to say, is there a right answer and a wrong answer? No, there really isn't. But there is probably going to be an answer that's optimal for the specific situation that you're going to be using it. So like in this case, if you have specific instances of a yacht, and you want to keep common information together so that it doesn't have to be duplicated in every single instance of the yacht, here you go. It is a way to do this. Now, you have patterns that can potentially be mixed. And we'll look at this one here because notice you've got a customer and the customer has an order. And you have a salesperson and the salesperson has an order. And the order might have a specific line item because it can have multiple items that go in the order. So you're going to have another piece that deals with items. A little bit more complex because the customer isn't necessarily only related to sales. And a salesperson obviously can have has a potential relationships to their sales order. But in this specific sales order, it's typically, it's only 0 or 1. You either had a salesperson or you didn't, but there's not multiple salespersons listed on a single sales order and not multiple customers listed there. So just see a nice, there's a little bit of but again, a nice interesting pattern to work with. Note how we have it delineated here. So looking for patterns, what do you look for? Multi-valued composite groups, and the element of a composite group is an identifier for another strong entity. So in other words, and that's what you see in that case. So strong, it can be an identifier for something else that doesn't necessarily need an identifier, but it does become an identifier for that. And you've got multiple things that actually go together to form, to for the pattern for that there's multiple multi-valued groups coming in. So saying in this case that you've got a customer and a salesperson to produce an order and specific line items, okay, those two go together to give you that actual sales order. But also I want you to note that in this specific pattern, the salesperson may or may not be required to be part of that sales order. And a customer doesn't actually have to have sales, have been involved in any sales. And notice, might not have bought anything. And you see that through the 0, 1, or many relationship between customer and sales order. Okay. Is this complex? Well, yes and no. It is complex in one way, but the reality is it should also seem to have a certain logical sense to it, which is one of the things you're going to see when we're going to go in and we're going to do some discussions of some of these that you're going to model and look at the different possibilities that you can have for modeling things. So we're going to move forward here. Some other types of mixed patterns. This pattern is kind of a tough one here because you have a recipe, okay, has a name to the recipe itself, and there's specific ingredients that are in the recipe. But if you look at the concept of an ingredient use, the ingredient will have a name, and we have hard-coded in here the name, the description, how much you have, and where it's located. Now the ingredient's being used inside of a recipe, so it does have both of those that go together. And the assumption in this case is that the ingredient use is particular to that specific recipe. So the recipe always has a specific ingredient. And the name of that may be all that you actually need here to do the recipe itself. You don't necessarily need to have a description, amount, how, storage location of an ingredient for it to be in a recipe, which will take you back to the other example that we had. You don't necessarily need a salesperson to have a sales order. Okay, again, and you can see that annotated with the annotations that you have here. So in this case, the ingredient use piece says this is an ingredient being used in a recipe. There actually is a hard connection between the recipe and the use of that specific ingredient. Again, other mixed patterns that you can see here. An employee skill needs to have an employee. Do you need to know about the description and salary range that go with that employee? Not necessarily, but there is potential for a relationship between the two of them. You do need the employee to have the employee skill. Okay, and in this case, you've got an employee with multiple skill numbers, and that skill is skills, which can be described over here to the side, are independent of they're independent of the employee or even the employee skill entities. They just exist over here to the side. But it's nice because in this specific pattern here, the employee has a skill and the skill description is kept off to the side so that it can be reused by multiple employees in that employee skill table. Kind of hoping that you guys caught that. Okay, I know sometimes it's really, you look at this, it's like, what's going on? I'll just say it one more time. You have an employee. The employee has a skill. It's called an employee skill. You make an annotation that the employee has the skill, but the skills are their own entity to the side. And in the case of the employee skill, you have that relationship back to those skills. Now, here's a really good example of a use by pattern, and a use by pattern that actually is from a form, which is very much database bread and butter, taking forms and turning them into a database. This one's a good one because it's a fishing license, but you notice that you've got a commercial fishers only and a sport fishers only. So now what you've got is the ability for a use by pattern where you're looking at saying, okay, you got a fishing license, but it's going to be either a commercial license or a sports license, and in the case of a commercial license, it's going to have this information. Now, note that the vessel is off to the side. It can be its own entity. Now, if I were just modeling this form, and only this form, these would have no use other than in this form, I could model the vessel information underneath commercial license information and sport license information underneath sport license information. And in that case, I wouldn't necessarily worry about making that relationship go off to the side. So again, what I'm saying is one correct and one not correct? Well, they're both correct. And in the case of this one, because you could have multiple vessels associated with a commercial license. Now, how would you deal with that in the specific case of this form? Because the form only has one spot here. Now, you do have a lot of room, so you could actually put in multiple vessel numbers and vessel names, but more than likely what you would do is you would fill out a separate form for every single vessel, the way that the actual practice is designed here. But in the database, we wouldn't necessarily need to do that. I know, sounds a little bit confusing, but your data management practices will also mirror your business practices. So having information of how the business practices are performed help you in the design of the way that you're going to actually model the entities. Yes, that is the way it is. Now, you've also got recursive relationships. And basically, a recursive relationship is when you have an entity that has a relationship to itself. Okay, we have a situation here where we're talking about boxcars. It's a horrible example, but it's what I had. But in this case, you do have a boxcar that might be keeping track of the boxcar in front of it and the boxcar behind it. And if you've had other classes with me, you know that that is essentially now a linked list. Great. Okay, but you do have to model linked lists. And linked lists are another, I mean, that's that in data structures. That is, and you model those in code. But you know what? If I turned around and said, hey, you've modeled the linked list in code, now turn around and model it with an ERD. You should be able to do that, and it's just a simple recursive relationship. Now, that was a one-to-one recursive relationship, and here's another one. You can have a one-to-many recursive relationship where employees have the ability to either manage or have specific relationships to other employees, and you can keep all of those, the relationship, like in the manages, within the employee table. So you're keeping a link to other employees, but you're not creating an outside table to do that. So in this case, remember that they're optional because you don't have to have that relationship, right? That one is, so recursive patterns, and recursive patterns, yes, they are common. That's not saying, oh, this might happen to you. This will happen to you. If you do any data modeling whatsoever, you will have recursive relationships where you have in an individual table a relationship to the table itself. And one of the other possibilities is the, okay, it may not be just one to n, it may be many to many, or in this case, n to m. N to m just indicates, n to n is used a lot. N to m is actually more accurate because it's saying that each of these does not have to have the same number. N to n seems to, n to n seems to imply that the number, which can be greater than 1, I'm going to be a 1 to 1, 2 to 2, 3 to 3, 4 to 4. That's actually not the case. The value on the left side and the value on the right side can be different. Okay. But you've got, and this is just an example where a part can be made up of other parts and parts can be in multiple other things. There you go. Now, example. We're going to take the good old Highline University database, which is going to track colleges, departments, faculty, and students. And we've got some reports we're going to use. These are like paper reports that are going to be what we use for the data model. So we're going to pull these reports. Like in this case, you have a report here, And you're going, okay, well, I can obviously see that I have a college. It's got a dean. It's got an address. It's got a phone. It's got multiple departments, each with chair people, with phones, and total, and it's got a number of majors. Now, that would be essentially in this case, how many students do you have in the major? But you've also got a department. Now, the department could potentially have more than one major, because a major typically refers to an academic program. So an accounting can have an associate's and a bachelor's. But in this case, the form itself only says, hey, there's 318 people in majors in accounting, and it's got this chair, and it's in this college. So how would you model this information? Well, the college seems to be indicate that there is this information from the form that is in that. That's the one right there at the top. Okay. Now, each of the departments has some information: chair people, phone, and total majors. So from the information that is in the actual report, this would be the logical data model that you would be looking at. Okay. Now, if we go one step further and look at the report, so if we go back here to the college, you had accounting, finance, info systems, management, and production as the departments. We took the header information and made that an entity. We took each individual row and made that its own entity, and then developed a one-to-many relationship. Now we've got the departments, which have its specific information, okay, and more information, which is the individual professors' offices and phone numbers that are in it. So now we've got some information that goes one step further. The department has some more information, and then we have professors that are there. But the reality is that professors can actually work for multiple departments. So we've actually made this an N-to-M relationship. There would be more information typically, because when a professor works for multiple departments, there's an appointment. So there's actually a role that they serve in the departments. So there would be probably something else that's in there that deals with the professor and the department relationship. But we're simplifying this now based on solely what we have on those forms. Another possibility is just to say professors go, many professors associated with a single department with 1 to N relationship. Now, which one do we use? Well, this has got a lot to deal with the business case. The N to M relationship is definitely more complex to manage in tables and in the ERD. Well, the ERD doesn't look that much different because it's just got a single line versus a multi-line. But when you actually build a database around this model, it is more complex to do the multiple in there. And there are other ways to do it. So there's that 1 to N relationship. So what can we do there? Well, we could go ahead and say, let's make it make another entity called an appointment that describes the relationship between the professor and the department, and make a 1-to-many to the appointment and 1-to-many between the professor and the appointment. And now you've got an association pattern. Which one of these to do? Well, again, depends upon a little bit depends upon the business case, the business model of how you want to do this. The most flexible of the patterns is alternate 3 here. It's the third one. It's going to give you the greatest level of flexibility, but it does it at the expense of complexity. So you've got the association pattern. And the other thing is that chairs are also faculty, the professors. So now we're going to throw up another relationship in there between department and professor, but only to a specific professor. So you've got that relationship to, and the appointment is fixed. So you could model the chair relationship with the appointment, with them being the chair. So your terms would be chair, or title would be chair, and the terms would be role of chair. Or you could have another relationship here in the department, which just points individually at the chair. So now we've got a fourth relationship. And, again, which one of these is correct? It can be modeled with this, which is this one with the association pattern. It can be modeled with this. Well, one of the things is if you're going to create an association pattern, which means that you're probably going to create an association table in a database design, any queries that constantly go and pull the chair from a professor list are going to have to go through and join to the appointment table. So that level of complexity does add real complexity to it. And now we got students that are in those majors. So guess what? We're going to add to this. And we're going to be adding students. Well, students go to the department and they do it through the relationship of a major. So that one wasn't terribly hard. And where do we use this data? Well, one of the things would be is an auto-generation of an acceptance letter. So note, if you look at this specific acceptance letter, these are auto-generated. They go to the database and so student address, dear student name, you've been admitted as a major in accounting department. Okay, that's a variable. Starting in the fall semester 2005, that was probably going to be a variable. The Office of Accounting Department, variable, is located in the business building, variable. Room 210, variable. Your advising professor is Elizabeth Johnson, variable. Whose telephone number is 2328. Okay, variables. In this case, I don't know if I read that because I don't know if you can actually see very well which one of those are bolded, but everything that's a variable is bolded. And how do you use that data? Well, you generate something like these types of letters. So, but notice that there was a relationship in that letter. Okay, we have that relationship, advises or advised by. So the appointment to the professor to the student gives you a relationship. So an appointment from a professor would be advising an appointment to a student, and you can actually model that again with another relationship here. And do we... How are we going to take that major? Because remember, we also said that they were a specific major. But in this case, we made the assumption that the department only had one major, which is very often not the case. Which means that we would probably need to break off the major as an entity, which would have a multiple relationship to the department, and the student's relationship wouldn't necessarily be to the department, it would be to the major, but because the major has a relationship to the department, you would get the connection back to the department. Okay, hopefully you listened to that. This is a model. I put that question mark as major as an entity. Hint, 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 hint. You may see this again. Okay, how would you model this? Okay. Just saying, those people that listen to me. That is it. I'm going to give you some good questions to talk about this on the discussion board, and you're going to get to start on your project. We're going to get to start doing this. So have fun. This is actually modeling data because it very much, it's kind of like programming. It does activate decision points. And I enjoy data modeling, especially the really challenging problems that you can come up with in it. So I hope that you can find some fun and pleasure with this. On out.